Hello and welcome to MarkLogic University's on-demand course covering bitemporal. This self-paced tutorial will show the basics of bitemporality within MarkLogic. These concepts are explained in detail in the documentation which can be found at docs.marklogic.com. For this on-demand course, it is assumed you have participated in our administrator's course, and are comfortable creating databases and using the available interfaces. This tutorial will last about 16 minutes. What did they know, and when did they know it? The MarkLogic bitemporal feature helps to answer this critical question by tracking how data changes along two dimensions of time, and is the only NoSQL database with this capability. Bitemporal functionality makes it possible to see information as it actually was, in combination with how it was recorded, from the perspective of a specific point in time. This capability gives you more power to go back in time and explore data, manage historical data across systems, ensure data integrity, and do complex temporal analysis with ease. This can be of critical importance for anyone in a regulated industry. Because the bitemporal feature is built into the server as part of our intelligent data layer, you inherit the benefits of other features such as tiered storage and semantics, all while maintaining security and transactional consistency. Much of the data that is being dealt with on a daily basis is temporal in nature. For example, it may be records of addresses, or details for an asset on a given day. Current unitemporal solutions are very good at being able to provide answers about how it was recorded, but not necessarily about how it occurred. Was there a gap between when it happened and when it was actually recorded by the system? If I ran my query during that gap, what would the results look like? What if I ran the query again just after it was recorded? Bitemporal enables you to query the data to see it as it actually was at a given point in time, versus as it was recorded, providing new insight into areas of your business that would otherwise be very difficult, if not impossible to obtain. In addition to specific answers, bitemporal can help support important business-level initiatives required to support the enterprise. With the ever-increasing regulations enforced by legislation such as Dodd-Frank, financial and insurance institutions are required to be able to answer detailed questions to auditors and regulators as far back as 7 years, plus all transaction history has to be preserved, not only as it is, but as it was, to clear audits. With many types of transactions, parts of the business generate continual updates. Those updates are applied to a record over time to more accurately reflect past or current state. Bitemporal will enable the business to see the changes over time that have occurred against the data with precision and repeatability. And finally, bitemporal functionality can help the business make better decisions by providing a more accurate picture of the past when a particular decision was made, thereby providing more insight for future planning. The ability to look back in time to follow the history of a transaction, and how it changed can provide incredible value to organizations, no matter the industry. Bitemporal functionality can help you to address increasing regulatory pressure and maintain a definite transaction history for audits. This data could also be available for business analysis and risk management purposes. How can you use bitemporality? In healthcare, you could watch for adverse events. What if a patient took a drug that created issues? When was it prescribed? When was it consumed? When did they experience symptoms? Insurance companies could track changes to coverage versus legislation. Was the appropriate coverage in place? In the intelligence world, bitemporal would allow you to combine a number of events against multiple timelines, and rewinding that information to identify additional related details not previously known. Cold case files could be worked by law firms. What did we know and when did we know it? Legal document processors could check if a particular law enacted was retroactive. What are the implications? When that law modified over time, what was the effect on a specific date? Lastly, for financial services, who could review the life of a trade, and see the changes that occur over time, be they corrections to quantities, or corrections to prices. This is by no means an exhaustive list of uses, and these uses are not restricted to the industry mentioned. Bitemporal works using two timelines, valid time and system time. The valid time is when the information was true in the real world. This valid time needs to be provided as part of the temporal document. The system time is when the information was stored in the database. System time may also be called transaction time. System time is managed by the system, except in cases when the system start time is set by the application. More details can be found in the Temporal Developer's Guide at docs.marklogic.com. This is an example of code to insert a temporal document into a temporal collection, named temporal collection. We will show later how a collection is set up. A temporal document is just like any other document, except it has to have 4 extra timestamps: system start, system end, valid start and valid end. The system time range tells you when this version of information is true for the database. The valid time range tells you when this version of information is true for your business logic, in the real world. We can see that after the ingestion, the system times are being populated. The system start time would be the time this insertion is performed and system end will be infinite. Bitemporality is defined on a protected collection, known as a temporal collection. A temporal collection is a logical grouping of temporal documents that share the same axes with timestamps defined by the same range indices. You can create additional temporal collections if you have documents that require a different schema for the timestamps. When a document is inserted into a temporal collection, a URI collection is created for that document. The original document that is inserted into the database is kept and never changes. When the document is updated, a new document representing the update is inserted into the document's URI collection. Any new document inserted into the temporal collection will have its own unique URI collection that will hold all of the versions of that document. Additionally, the latest version of each document will reside in a latest collection. In this way, a bitemporal document can be rolled back to review, at any point in time, when the information was known in the real world and when it was recorded in the database. We will now walk through a basic use of bitemporal. This will entail creating 4 range indexes to be our axes. The axes will have to be created, along with a temporal collection. Then we will be able to insert temporal documents. This demo will be done entirely from the query console. We have created a database called BitemPDemo. Please note that it will be used as the content source for all of the queries. This workspace will be available for download. If you wish to recreate this on your own system, please ensure that the name of the content source you use is entered into the function call on line 5 in the first query, and that you are consistent in selecting the same content source throughout the workspace. In this first query, we are creating 4 date-time range indexes. 2 for our valid times, and 2 for our system times. It does not matter how you choose to create these. With this being the query console, we will click the Run button to execute the query. The temporal axis create command that is used in this query will set 2 of the range index as the valid temporal axis. These range index need to be of the date-time type. Be careful that the names of your range indexes are spelled correctly. This query will add the other 2 range indexes as the system temporal axis. Again, be sure that everything is spelled correctly. Now we will create our temporal collection. To do so, you need to specify what you want the collection to be called. The name of the system temporal axis. and the name of the valid temporal axis. Normally, you would let your MarkLogic installation set the system start time automatically. But, we need to simulate documents being entered at specific times. In order to do so, we need to set the last stable query time setting to true. If this is not done, our attempts to specify a system time for our documents will result in an error. This functionality could be useful if you are looking to roll data off of an old system, while still maintaining the system time of the original system. Here is our first document. The premise here is that a trader named Jason is looking to place an order. He is looking for a price of $12. The order is placed at 11 a.m. and the order is added into the system at that time. Again, remember that if the last stable query time is still at the default value of false, the set system time function call will result in an error. This order will remain valid until the close of the market at 4 p.m. For our second document, Jason has been looking at the history of the stock. He realizes that the price seems to dip just as the market closes. So, he wants to change his order. Now, his order will only be for the final moment of the trading day. His changed order was added into the system at 11:30. We are about to start querying our temporal collection. To do so, you can use both ISO and ALN algebraic operators. The ALN operators will have a prefix of ALN, and are generally more restrictive than the ISO operators. The ISO operators will have a prefix of ISO. For full details on these operators, please refer to the Temporal Developer's Guide. For our first test, we will look for the documents that were in the database between 11:10 and 11:15. Remember, the second document was not added until 11:30. The search is being done with the normal CTS search call, but will use a new CTS temporal function, period range query. Since we are wanting to check when the document was added to the database, this search will reference the system axis. Our first test was a success. The original document was returned, since it was the only document in the database between 11:10 and 11:15. For our second test, we will be using the valid axis. We will look for documents who have a valid time period that starts after 10:30 and end at 3:59. The result is interesting. It looks like the original document that we added to the system, with a price of 12. But, look at the system start time, and the valid end time. What is going on? When the new document was added, it used the same URI as the original. That original document, listed here as document 1, was then split or forked, creating document 2, at 11:30. Document 2 will remain valid, until the new document, document 3, takes over at 3:59. Next, we shall search for documents which were added to the database after 11:20. Given what we just learned, how many documents do you expect will be returned? The result is 2 documents. The split from the original document, document 2, is returned, along with the updated document, document 3. Our last search will look for documents whose system time period contains the valid time period. This means that it became valid sometime after it was added to the system. The system time of the original document was exactly the same as its valid time. Document 2, created by the fork, was valid 30 minutes before it was added to the database. Document 3 is the only document which became valid after it was added to the database. Congratulations! You have completed this tutorial. In this tutorial you were introduced to bitemporal concepts and you saw how to apply them within MarkLogic. You saw how to create temporal axes, temporal collections, and how to search using the valid and system times. Thank you for attending this MarkLogic on-demand course. Please visit the MarkLogic University for a complete selection of on-demand topics.